Hello, third graders. I hope you are having a wonderful day. We are still in our astronomy unit, our solar system and beyond. This is lesson 7, the beginning of the universe. Some vocabulary you'll hear in the read aloud. Big Bang is a scientific theory of how the universe began. Compressed means pressed together into less space. Data is facts or pieces of information that have been collected, often in the form of measurements. Elements are the basic substances found on Earth and in the universe, each made of only one kind of atom. Evidence is something that makes a statement clear and believable. Expanding means becoming larger, increasing in area, spreading out. Phenomenon is a noun. It means it's an interesting fact or event that can be studied. And theories are suggested or widely accepted explanations for why things in the world happen. So what have we learned so far? A star is a star. All stars are the same. Is that true or false? No, not all stars are the same, right? They're different sizes, they're different heat. Some of them are really hot and some of them aren't as hot. They're different colors depending on how hot they are. Reddish stars like Betelgeuse are not as hot as bluish stars like Regal. That's true, the bluish stars are hotter than reddish stars. Reddish stars are the least hot. Our galaxy, the Milky Way, is irregular in shape. Do you remember? Is it irregular in shape? Our sun is a yellow, medium-sized, medium-aged star. That is true. It is yellow and medium-sized, medium-aged. Galaxies are clusters of billions of stars. Yes. Another name for the North Star is Sirius. Do you remember? The universe contains billions of galaxies and extends to vast distances beyond the imagination. We've been talking a lot about the universe these past few days, but what exactly is the universe? The universe is everything that exists, all matter, all energy, and all the space between things. Look around you. Look at the room you are in, at the people who are around you, even at the air you breathe. It's there, though it's kind of hard to see. Think about your school, your neighborhood, your community, your state, and your country. Picture the whole earth in your mind. Picture all of the oceans and mountains, animals and plants and rocks and water, and all the things that you have ever heard about or seen on the earth. All these things are part of the universe, but the universe is much bigger than all of these things on earth. The sun, the 8 planets in our solar system that orbit the sun, and the huge distances between them are all part of the universe, too. So are all of the other objects in our solar system, all the satellites that orbit the planets, the asteroid belt, comets, and meteoroids. But the universe is bigger than the solar system. Do you remember the 8 planets of the solar system in order from the sun? We have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Neptune, or Uranus, Neptune, right? And then do you all remember where the asteroid belt is between 2 planets? When you look up in the sky at night, you sometimes see the moon or a planet that is part of our solar system. You also see beyond our solar system stars and constellations that are all part of our Milky Way galaxy. The Milky Way is huge, and every single part of it is also part of the universe. There are billions of stars in the Milky Way. The Milky Way galaxy is enormous, but the universe is even more astronomical in size than the Milky Way. If the sky is very clear and you know where to look in the night sky, you can see another nearby spiral galaxy. That's right, the Andromeda galaxy. Like the Milky Way, it is a spiral galaxy, but it may have up to twice as many stars as our Milky Way. Scientists believe there are billions of galaxies, each containing billions of planetary systems, and all of them together make up the universe. But the universe doesn't just include the matter or stuff that the stars are made of. The universe also includes all energy, time, and space. As you can tell, the universe is big and it includes things we can see as well as things we can't see. In fact, the universe is so big that we don't even know for sure how big it is. But just because we don't know exactly how big it is doesn't mean that we can't study it and learn more and more about it. Scientists learn more about the universe every day. The new discoveries they make help form ideas or theories about the universe. A theory is an explanation about something or a reason for something. Scientific theories are not just guesses, they are explanations based on evidence or information that scientists get by making observations and taking measurements. Frequently, there are several different theories that seek to explain the same phenomenon. All right, so they're not necessarily guesses because there's facts and evidence behind them, but theories aren't necessarily for sure true, right? They're what scientists believe is an explanation for something. So scientists gather new data to help select between these theories. They share the data and study it to look for patterns and answers to questions. When new evidence is discovered that supports a theory, scientists' belief in that theory is strengthened and it becomes clearer and more certain. When something new is discovered that goes against the theory can be changed or readjusted to take the new evidence into account. Sometimes new evidence can show that a theory is totally wrong. Then a new theory takes its place that explains the evidence better than the old theory. So scientists learn new things, and sometimes they discover that what they thought was true, what their theory was actually wrong. And then they try to figure it out again. It's the whole job of a scientist. Here's an example of a theory that changed based on new evidence. For many, many, many years, humans have looked up into the sky and observed the stars. They have developed stories and theories to explain the universe. In the distant past, most humans believed the theory that Earth was the center of everything that was known. But then, in more recent history, around the time that Columbus made his famous voyage from Spain to the New World, scientists like Copernicus and Galileo discovered new evidence that proved that was not true. So a new theory that Earth was not the center of the universe took its place. Today there's a common theory about how the universe first developed called the Big Bang theory. It's a theory that is well tested and widely accepted by many scientists, but not by everyone. The Big Bang theory seeks to explain how the universe may have come to be, and it began with a tiny speck. That's right, according to the Big Bang Theory, before the universe was the way it is today, it was believed to be very different. There were no billions of galaxies, there was no Milky Way, there was no stars at all, no sun, no solar system, no planets, no Earth, no moon, no asteroids, no comets. There may not have even been time or space. All of the ingredients to make everything we see today were there. They were just in a very different form. It's hard to imagine, but the Big Bang Theory traces the universe back to a point where all of what we can now see in the universe was compressed into a teeny tiny speck. This speck was jam-packed full of, well, everything. It was unbelievably dense and crowded. This speck was also super hot, hotter than anything on Earth, hotter than the sun. Around 14 billion years ago, something amazing happened to all that compressed stuff. Kaboom! A bursting forth, a moving outward, a rapid unfolding. It's been called many things by many people, but this amazing thing that happened is believed to be the Big Bang, the birth of the universe. It was hot and it was sudden and it was powerful. In a fraction of a second, space that had not been there before was suddenly everywhere all at once. Tiny new particles formed and began crashing into each other, creating energy and eventually joining to form larger bits of matter. The universe kept expanding and expanding, all of its matter spreading out as the universe kept getting larger. And as the universe expanded, it began cooling down a little at a time. According to this theory, the newborn universe was nothing like it looks now, and at an estimated 14 billion years later. Remember, that's an estimate, that's just what scientists think, it's part of their theory. But then there were no stars yet. Back then, there were no stars yet, and there wouldn't be for the first 100 million years after the Big Bang. The universe kept expanding and cooling. Substances kept crashing into each other, and brand new bits of matter were formed. Eventually, new gases were formed. As these gases began to cool, they collapsed because of gravity and formed the first stars. The universe kept expanding and stretching, and more stars were born. Then galaxies formed. And after 9 billion years, about 9 billion years after the Big Bang, our sun and solar system were born when gases collapsed in on themselves and formed our sun. That was believed to be a very little over 4.5 billion years ago, but the expansion of the universe and the creation of new stars still goes on today. Okay, just think all those numbers and those theories come from different observations that scientists have made to come up with their theory. Many scientists believe that the universe is about 14 billion years old, but no one on Earth has been alive nearly that long. Even Earth hasn't been around that long. The truth is that no human being saw the universe as it was being formed. So, how did scientists come to believe this theory is true? Good question. You know how you sometimes make predictions before you hear a read aloud? Over many years, scientists have made predictions based on 3 pieces of evidence they have observed to be true. This evidence supports their prediction that there was a Big Bang. The first piece of evidence that supports the Big Bang theory is that the universe is expanding. Remember how we said when the Big Bang happened there was a sudden unfolding and spreading out of the universe? The expansion continues today and it has never stopped. Scientists have taken many measurements that prove this to be true. The data that astronomers have gathered are evidence that the galaxies are still moving farther and farther away from each other. And the farther away the galaxies are, the faster they are moving. Because scientists know that galaxies are now moving away from each other, it makes sense that they were closer together in the past. This is exactly what the Big Bang Theory says, that about 14 billion years ago, everything was all together in one single, incredibly hot, dense speck. The second piece of evidence is the discovery of something called the cosmic microwave background. Remember how we said when the Big Bang happened, everything was incredibly hot and then gradually cooled down? The cosmic microwave background is believed to be the glow or leftover heat from the Big Bang itself. This glow or heat does not come from an object in the universe, but has been discovered to exist everywhere in the universe. Microwaves are one of the types of light energy given off by the sun and other stars. Even though they are invisible to us, scientific instruments allow us to view them. The Big Bang Theory predicted this leftover microwave light energy would exist in the universe, and it was indeed discovered in the 1960s. The third piece of important evidence that supports the Big Bang Theory is the amount of the very lightest element that exists in the universe. Some elements are heavier, like lead and silver, and some are lighter, like hydrogen and helium. The Big Bang Theory predicted that these lightest elements were created in specific amounts shortly after the Big Bang occurred. By measuring and collecting data, scientists have found that the amount amounts of the light elements in the universe today are extremely close to the amounts of light elements that were predicted by the Big Bang Theory. So you can see in this bar graph the amount of hydrogen and helium compared to other elements. The Big Bang Theory seeks to explain how the universe may have first come to be. These three pieces of evidence are great examples of how actual measurement of the universe support and strengthen the idea that the universe began with kaboom, a rapid, sudden expansion known as the Big Bang. For many scientists, discovering these three pieces of evidence that support the Big Bang Theory have been a real blast. Often in science, finding answers leads to new questions. As astronomers find more and more evidence to support the Big Bang Theory, they also continue to ask new questions and to continue to discover this theory. Maybe someday one of you will help to present a new theory that will include parts of this one or that is completely different. But for now, scientific evidence points to the Big Bang or something like it. Right, what is a theory? A theory is a suggested or widely accepted explanation for why something happens. How is a theory different from a guess? A theory is based on a lot of experiments, observations, and data. How can a theory be different from a fact? Think about that a little bit. We'll be discussing theories and facts and truths in our afternoon wrap-up. What was the universe believed to be like before the Big Bang? It was a tiny point or speck. Everything in the universe was compressed into one tiny point. It's very hot and very dense. What kinds of things do scientists do to gather evidence? They make observations through telescopes. They take measurements. They collect and share their data and study it to look for patterns and answers. Our word for today is expanding. In the read aloud, you heard the universe keeps expanding and expanding. Say the word expanding. When something is expanding, it means it is growing in size. The tire on Erica's bike is expanding as she pumps air into it. What part of speech is the word expanding? Is it a noun, an adjective, or an adverb? Or a verb? All right. Good job, third graders. Hope you found it interesting to think about some theories of how the universe began. I'm excited to hear some of your beliefs and theories during our afternoon wrap-up today.